Welcome back everyone. Session 6, API testing and network control. Up to this point, everything we've done has gone through the browser and the UI. Today, we step outside of that. Playwright can talk directly to your API, which means we can seed data in milliseconds instead of clicking through a UI flow. And we can intercept and control network traffic to mock responses, simulate errors, and speed up our tests dramatically. This session is really about using Playwright as more than just a browser tool. It's a full end-to-end testing toolkit. Quick recap of session 5. Page object model classes, custom fixtures through test.extend, fixture scoping, and shared login state through storage state. Today's agenda, 5 things. The request fixture for pure API testing. Combining API setup with UI verification in the same test. Network interception using page.route. Waiting on network calls with wait for response and wait for request. And testing authenticated applications. Reusing tokens across both API and UI calls. Let's start with why you'd even want to do API testing inside Playwright, rather than reaching for a separate tool entirely. Playwright actually ships a full HTTP client right alongside its browser automation, and the same test runner, the same reporter, the same fixtures. All of it works identically for both. 3 concrete benefits. It's faster than UI tests. There's no browser, no rendering involved, so API tests run in milliseconds rather than seconds. It's one single toolchain. The same assertions, the same config, the same CI pipeline serves both your API tests and your UI tests, so there's nothing extra to maintain. And it lets you set up state fast. Seeding data through the API takes a fraction of the time a full UI flow would take to accomplish the exact same thing. Let's meet the actual tool, the request fixture. Here's the code, test, gets a list of users, async, request, and inside it, const response equals wait request dot get slash API slash users. 3 things worth knowing. Request is a built-in fixture, exactly like pages. There's no extra installation required at all. It supports get, post, put, patch, delete, and head. And it's completely independent of any browser, though it's worth knowing that it does share cookies with page, specifically if you use page.request instead of the standalone request fixture. Let's look at the full range of what you can do. Get const list equals await request dot get slash API slash tasks. Post to create something passing a data object with, for example, a title of write KT slides. Put to update something, calling request.put with the specific ID in the URL and a data object like $true. And delete, request.delete, again with that specific ID. That's your complete create, read, update, delete toolkit. And honestly, the syntax maps almost exactly onto what you'd expect from any standard HTTP client. Let's talk about authenticated requests. Here's the code, request.get slash API slash profile with a headers object, authorization set to bearer, followed by your token, and accept set to application slash Mason. But there's a more efficient option too. You can set headers once for every single request coming from this fixture using extra HTTP headers inside your playwright.config.ts. That way you're not repeating the same authorization header on every single call throughout your test suite. Once you've got a response back, here's how you actually verify it. Const response equals await request.post, creating a task. Then expect response.ok.to be truthy. Expect response.status.to be 201. Const body equals await response.json. And expect body.title.to be x. Worth calling out, response.ok and response.status are generic assertions, checked exactly once immediately. There's no polling happening here, and that actually makes sense if you think about it. But there's no page that needs to settle, no rendering to wait on. The response either came back the way you expected or it didn't right now. Now let's combine API and UI together, which is genuinely one of the most valuable patterns in this entire session. 4 steps. Create test data through an API call. Skip the slow UI setup flow entirely. Navigate directly to the state you actually want to test. And assert that the UI correctly reflects that state. Here's the reasoning behind this. A UI test for editing an existing task doesn't also need to retest creating a task through the UI. That's exactly what the API setup step is for. Keep every single test focused specifically on what it's actually trying to verify and let the API handle everything else around it. Let's see this pattern in real code. Test. Editing a task updates its title, async page, and request together. First, we see through the API const created equals await request dot post slash API slash tasks with a title of draft KT plan. We pull the ID back out of the response with created.json. Then and only then do we touch the UI at all. We navigate to that tasks page, fill in a new title of finalize KT plan, click save, and assert that the new title is visible. Notice how focused this test actually is. It's testing exactly one thing, editing, and it's not wasting any time reproving that task creation works, because that's simply not what this particular test is about. Let's move into controlling network traffic directly. Page.route lets a test intercept any matching network request. You can inspect it, modify it, fulfill it with fake data, or block it entirely. Here's the basic shape. Await page.route with a glob pattern like star star slash API slash tasks and an async handler function where you inspect, modify, fulfill, or block the request. Two big use cases here. Mocking responses lets you test edge cases like errors or empty states without needing a real backend to cooperate with you. And blocking requests, strip out ads, analytics calls, or images specifically to speed up your test runs. Let's see mocking in actual code. Page.route matching slash API slash tasks. Inside the handler, await route.fulfill with a status of 200, a content type of application slash JSON, and a body that's a JSON string containing one mocked task. Then, from the test, navigate to slash tasks and assert that mocked task is visible. This is genuinely great for testing error banners, empty states, or slow loading UI, all without needing your real backend to actually cooperate and produce those specific conditions on demand. Let's look at blocking requests to speed things up. Await page.route, matching any image file extension, calling route.abort. Another route, matching analytics.js, also aborted. Then we navigate to slash dashboard and it loads noticeably faster without images or analytics weighing it down. One real caution here though, use this sparingly. Blocking things your app genuinely depends on, like fonts or core scripts, can actually hide real rendering bugs behind what looks like a faked fast page. Only block things you're confident are truly irrelevant to what you're testing. Beyond mocking and blocking, you can also modify a request before it actually goes out. Page.route, matching any API call. Inside the handler, we grab the existing headers, spread them, and add a custom header, x dash, test dash run colon, nightly. Then await route.continue, passing in those modified headers. 3 methods worth distinguishing clearly. Route.continue sends the request onward, optionally modified along the way. Route.fulfill response directly. the real request never actually fires at all. And route.abort cancels the request completely. Sometimes you don't want to mock or block anything at all. You just need to confirm that a network call genuinely happened. Page dot wait for response with a URL waits for a matching response to come back before your test proceeds. Page dot wait for request waits for a matching request to actually be sent out. And just like wait for event from session 4, register these before the action that triggers the request and pair them with promise.all, exactly the same pattern we've used before. Let's see this in a real example. Const response in brackets equals await promise.all page.wait for response, checking that the URL includes /API/tasks and the status is 201 alongside page.getByRole button, save.click. Then expect the responses JSON title .2b finalize KT plan. What this actually confirms is genuinely more than what the UI alone can tell you. It's not just that the UI shows a success message, it's that the correct request actually reached the server and the server actually responded with the outcome we expected. Let's talk about tokens, spanning both UI and API together. 3 approaches. Reuse storage state, the exact same auth/user.json file from session 5 carries cookies into your page. .request calls to automatically. Fetch a token directly through the API. Skip the UI login step entirely. Post credentials, grab the token back, and set it as a header yourself. And a worker scoped token fixture. Fetch that token exactly once per worker and reuse it across every single test in that worker that needs authenticated API calls. Let's cover today's anti-patterns. Mocking everything. Over-mocked tests stop actually catching real integration issues. Only mock what's genuinely needed for the specific scenario you're testing. Overly broad route patterns. Something like ***/ can accidentally intercept requests you never actually meant to touch at all. Forgetting route.continue, a route handler that never calls continue, fulfill, or abort, just hangs that request forever, and your test will time out in a confusing way. And testing API covered logic through the UI, redundant UI tests for things already proven at the API layer, just waste your suite's overall runtime for no additional confidence. Let's put everything from today together in one complete realistic example. A test called shows an error banner when save fails. First, we seed a task through the API. Then we set up a route that intercepts that task's API endpoint and fulfills it with a 500 error status. Then we navigate to that task in the UI, click Save, and assert that a something went wrong message becomes visible. This test seeds through the API, mocks a failure through network interception, and verifies through the UI, genuinely all 3 techniques from today, working together in one focused test. Your turn. 5 things. 1. Write a pure API test using the request fixture. Create a resource, read it back, then delete it. 2. Seed a record through the API, then navigate to it in the UI and assert it renders correctly. 3. Mock an API error response and assert that your application's error state actually displays properly. 4. Block image requests on a page and confirm the test still passes on the content that actually matters. 5. Use wait for response to confirm a specific request fired after a button click. Let's recap. 4 things. The request fixture gives you full create, read, update, delete API testing with 0 extra setup required. Seed data through the API and keep your UI tests focused only on what they're actually meant to verify. Page.route can mock, modify, or block any matching network request. and wait for response or wait for request confirm that a call happened without touching or altering it in any way. Next time, session 7, cross-browser, parallelization, and CI/CD. We'll configure multi-browser and mobile projects, run things in parallel with workers and sharding, handle retries and flaky tests properly, and wire everything into an actual CI pipeline with GitHub Actions. That's where your suite goes from running on your laptop to running at scale automatically on every single commit. Any questions, please post in comments section.